Good morning, good afternoon, good evening, ladies and gents. And in today's video, we're going to take all of our exponent rules that we looked at over the last couple of parts, and we're going to do questions where we're looking at them together. So in this first question, these questions here are like bronze level questions, I would say, which are basically like knowledge and understanding type questions, questions that can be done in 1.5, 2 steps or so. Okay? So when you're looking at the questions, so first things first, you always want to factor or change all of my exponents, my bases to be the same base. So change everything to same base. That's if you can. So over here, I see 3 squared to the power of 5 and a 9. Well, 9, I know, I'm going to put this up here, 9 is just 3 times 3, which I know is 3 squared. So going back to this problem, I can change that 9 to 3 squared. Okay? The next thing I'm noticing is I have a squared in the inside of the bracket and a 5 on the outside of the bracket, and as we know, that means I am multiplying those exponents, so that should be 3 to the power of 10. So now when I'm looking at this, I have the same base on the top, same base on the bottom, so you apply your appropriate exponential rule. So apply exponent rule. And for that, you should review for the last couple of videos. But in this case, it's a division and they're the same base. So we subtract their exponents. So my final answer should be 3 to the power of 8. Okay? Now, there is a third step sometimes, and we're going to see what happens when we get to that third step here in part B. So in part B, can I do step 1? No, they're already as small as they can get, can't do anything there. So we go to step 2, which is you have the exponent on the outside, so that it should apply to both of my exponents. Not the base, we don't touch the base. So it'd be a to the power of 2 times 2, which is 4, b to the power of 3 times 2, which is 6, divided by a to the 6, b to the 5. Now we're going to use the second rule. So same base, everything is multiplying, there's no addition, no subtraction, so I can use my exponent rules. So the 4, the 6, the 5 are going to be subtracted. So I'm going to have a to the power of 4 minus 6, which is negative 2. And b to the power of 6 minus 5, which is 1. Now the problem is, you have here a yellow light here. You have a yellow light because it is a negative exponent. And we don't like having negative exponents in our final answer. So my last step is I'm going to move the a to negative 2 to the bottom, making it a squared. And that's my final answer. So let's take a look at some step-up more questions. Let's look at the silver questions. So in these questions, you're going to see the silver level type of questions. And you can see that there's more going on. You have more steps going on here. So once again, you're going to change your base. Okay? So you want to change all your bases. So 32, can I make 32 and 4 into the same base? Yes, I can turn 32 into 2 to the power of 5. And I can turn 4 into 2 to the power of 2. Okay, apply my rules. So it's going to be 2 to the power of 10, a to the the power of 4, b to the power of 6, 2 to the power of 6, a to the power of 6, and b to the power of 21. Apply the next rules. 10 minus 6 is 4, so it's going to be 2 to the power of 4. A to the power of negative 2. B to the power of negative 15. So my final answer would be, well, 2 to the power of 4. 2 times 2 times 2 times 2 is 16. Bring everything with a negative exponent to the bottom. And you're done. So in addition to the first two steps that we did on the other page, you have a third step here, which is negative exponents must change their position to turn positive. So over here, imagine this is like all of this over 1. So you're going to bring this to the bottom to turn them positive. Okay? And our next question here, can I do anything here with my 21 and my 49? Not really. You can't turn that into bases. Now, in these type of questions, when you can't do that kind of step, you can simplify your numbers first. So put this on the side here. If I told you simplify negative 21 over 49, well, I know that they can both be divided by 7, which would give me negative 3 over 7. So negative 3 over 7. And just like that, you're done with your numbers. Now you move on to your other stuff. So now I have a to the negative 3, a to the 5, so that's negative 3 minus 5, which is negative 8. And b, 7 minus 9, which is negative 2. Once again, these are negative exponents, so I'm going to be moving them down. So my final answer is going to be negative 3 over 7a to the 8, b to the 2. And that's it for the silver level questions. Now, what could happen when I can't get them to the same base and I can't simplify? Is there something I can do further? And that's what we're going to see when we go to gold level questions. So in the gold level questions, you have now your roots. As you can see here, you have a root here, you have the fourth root here. Here you have them in rational form. So your first step in these type of questions is to change the radicals into rational exponents. So change radicals to rational exponents. All right, and that's what I'm going to do. Here, even though I don't see anything, it's almost like there's a 2 there. So this is the same thing as saying to the power of 1/2. And I know 81. 81 is 9 times 9, or I can say 3 to the power of 4. I'm going to write that up there. 81 is 9 times 9, which is equal to 3 times 3 times 3 times 3, which I know is 3 to the 4. And then I have a to the 6, b to the 4. And on the bottom, this is the same thing as saying 1 over 4. Remember, the number on the outside becomes my bottom. And then the rest of it, 81. Once again, that's 3 to the power of 4. A 16, B 24. Now let's apply our laws. So I'm going to have 4 divided by 2. That's going to be 2. A to the 3, B to the 2. Then I'm going to have 3 to the 1. I want to write that down. A to the, 16 divided by 4 is 4. And 24 divided by 4 is 6. All right, let's apply our rules. So I'm going to have 2 minus 1. So this is really just 3. This is A to the negative 1, B to the negative 2. So my final answer would be 3 on the top. And once again, just like we did before, put the A and the B to the bottom to turn their exponents positive. Okay, you're changing their outlook on life. They're going from a negative person to a positive person. If only life was that simple. All right. Now, in part B, you have a different challenge. 36 and 16. Well, 36 can't be turned into the same kind of base as 16. So what you want to do with 36, you want to do some kind of prime factoring. Okay? So I know 36 can be divided by 2, which would give me 18. I know that 18 can be divided by 2 as well, which will give me 9. And I know that 9 can be divided by 3, which will give me 3. So by prime factorization, I have 2 squared times 3 squared. 2 squared is 4, 3 squared is 9, 4 times 9 is 36. So using that, I'm going to go in here and change my 36 into 2 squared, 3 squared. And then you have the A to the 9, B to the 6, 3 over 2. 16, I could just turn that to 2 to the power of 4. A to the 12, B to the 8, and this is all to the power of 3 over 4. All right, so let's apply our stuff here. So 2 times 3 over 2, that's just 2 to the 3. And that's just 3 to the 3. This is going to be giving me a fraction here, which is going to be 27 over 2. And over here, I'm going to be getting 6 divided by 2, which is 3. 3 times 3, which is 9. All right, and on the bottom, same thing. Okay. So you're going to be getting 4 divided by 4, which is gone, so you'll be left with 2 to the power of 3 as well there. And you're going to have 12 divided by 4, which is 3 times 3 is 9. And b to the power of 8 divided by 4, which is 2 times 3, which is 6. All right. Now let's see what we can cancel. I've got a 2 to the power of 3 on the top, 2 to the power of 3 on the bottom. They can go away. So what am I left over with? 3 to the power of 3, which is 27. And then next up, we're going to have 27 over 2 and 9. So if you want to put this on the side, that's like me saying 27 over 2 minus 9. So if you remember, this is the same thing as saying 9 over 1. You need common denominators, so you multiply the top and the bottom by 2. So this is the same thing as saying 27 minus 18 over 2, which is 9 over 2. So you're going to come in here, put that in there. So A, 9 over 2. B, 9 minus 6, which is 3. Now this would be a perfectly fine final answer, or you can write it like this: 27 square root of A to the power of 9. Okay? And then B3. Both of these are great final answers. All right, so last but not least, let's look at a ultra challenging question. Okay, so in this question, we're looking at a more challenging question, but let's use our rules and go into this as we can. So, in this question here, we have a negative exponent. Whenever we have a negative exponent, it's the first thing I want to get rid of. Now, to get rid of a negative exponent, what you're going to do is you're going to take your top, going to move it to your bottom, and vice versa. You're going to take the whole thing. So this whole thing is going to move to the bottom. This whole thing is going to move to the top. Okay, so that's going to give me 3 squared, which is 9. 1 minus 3 over x minus 3 divided by 5 minus 2 over x minus 3. And this would be to the power of 1 now. Okay? Now from this point on, it's just a matter of following your rational rules. So I notice here that I have a 1 minus a fraction, but remember, even though we don't see it, there is still a division of 1 on the bottom. So common denominators, you're going to have to multiply this by x minus 3, this by x minus 3, this by x minus 3, and this by x minus 3. Because remember, you want to have common denominators. It's going to be equal to 9 times, well, x minus 3 minus 3 over x minus 3. And remember, we're dividing by a fraction here. Whenever you divide by a fraction, it's the same thing as multiplying by the reciprocal. X minus 3 will now be on the top. And on the bottom, you're going to have that 5 times x minus 3, which is 5x minus 15 minus 2. And now what do you notice is there's an x minus 3 on the top, x minus 3 on the bottom. They're going to go away. Now, the reason why I can cancel that out while there is a bracket still is because the 9 is only going to apply to the top. Okay, so the bracket's only really on the top there. So that's going to give me, well, x minus 3 is x minus 6. Divided by 5x minus 17. Now let's finish it off. You're going to have 9x minus 54, because that 9 is going to go to both these terms, divided by 5x minus 17. And that's it. All finished. I hope you have understood all this stuff that we've done in the video. And if you have any questions, please let me know. Have yourself a wonderful day.